All right, let's just jump right in. If you're running anything on Kubernetes and AWS, EKS, you've probably wrestled with this. How do you handle AWS permissions securely? Well, today, we're going to break down the modern, the secure, and honestly, the only way you should be doing it. We're talking about IRSA.
But before we get into the solution, I've got a question for you, and it's a serious one. Are your Kubernetes pods a little too powerful? Because if you're not careful, they could be holding the keys to your entire AWS kingdom. And that's a massive risk you just don't want to take. So you might be wondering, how did we even get into this situation? Well, for a long time, the standard way, the old way, was pretty simple. You'd just attach an IAM role to the EC2 worker node itself. And guess what? Every single pod running on that machine, it inherited all of those permissions. Super simple, right? Yeah, but also super insecure. And this slide really lays out the problem, doesn't it? When you use that old node IAM role method, you get way too much access. I mean, think about it. You might have a simple app that just needs to read from one S3 bucket, but it ends up with permissions to manage your entire network. A single compromised pod could, in theory, delete databases, leak customer data, or even just shut down your whole production environment. That's not just a risk, that's a full-blown security nightmare waiting to happen. Okay, so this is where IRSA comes in to save the day. IRSA stands for IAM roles for service accounts, and it is such an elegant solution. The definition here says it all. It lets a Kubernetes service account assume a specific IAM role, and it does this using a technology called OIDC, which means, and this is the best part, you never ever have to store AWS credentials inside your pods. It's the principle of least privilege in action, a total game changer for security. So before we dive into the step-by-step of how this magic works, let's meet the key players. You've got your AWS IAM on one side and your Kubernetes service account on the other. They're connected by an IAM role with a very special trust policy. But the real bridge between these two worlds is the EKS OIDC identity provider. Now, I want you to think of this OIDC provider as like a super secure passport control officer for the cloud. It issues these secure, short-lived tokens that AWS IAM knows how to read and trust. It's all done without ever sharing secret keys. And the final piece that makes it all happen is a call to the AWS Security Token Service, or STS. All right, let's walk through this process. It's brilliant. Step 1, your EKS cluster makes that OIDC provider available, basically telling AWS, hey, you can trust tokens from me. Step 2, you create an IAM role, but you set up its trust policy to only trust that specific provider and, this is crucial, only for a specific service account in a specific namespace. Super granular. Third, you create that Kubernetes service account, and you just annotate it with the role's name. Fourth, your pod gets launched using that service account. Now this is where the magic happens. Step 5, the AWS SDK inside your pod, totally behind the scenes, grabs a token and calls STS to assume that role. It gets back temporary credentials, and finally, step 6, your pod can now securely talk to the AWS services it needs, and only those services. Beautiful. So if you remember just one thing from this whole process, let it be this. This is the crucial point. No static AWS credentials. No access keys. Nothing is ever stored, mounted, or configured inside your pods. Ever. The credentials are all temporary, they're rotated automatically, and they're scoped only to that one pod. It's just a completely different level of security. And this table just puts it all in black and white. Or, well, red and green. It's a direct head-to-head comparison, and you can see it's not even a fair fight. When it comes to real security, workload isolation, and sensible credential management, IRSA just sweeps the board. It's not just a best practice anymore. For modern cloud infrastructure, this is really the required standard.
So let's just recap why IRSA is the undisputed champion here. 1, you get pod-level IAM permissions, super fine-grained. 2, no AWS keys inside your containers, period. 3, credential rotation is completely automatic, handled by AWS. And 4, you get truly strong isolation between your different apps. These right here, these are your gold standard talking points.
And look, this isn't just some abstract theoretical concept. You see IRSA in action all over the place in the real world. You know the external DNS controller that needs to mess with Route 53? That's a perfect use case. The ALB ingress controller managing your load balancers. Yep. What about your app pods that need to pull secrets from Secrets Manager? Or your CI/CD pods pushing new images to ECR? All of these are prime examples where IRSA is the clean, secure solution.
Okay, so you're in an interview or a design review, and someone asks you to explain IRSA.
Here it is. This is your perfect one-liner mic drop answer. IRSA and EKS allows Kubernetes service accounts to assume IAM roles using OIDC, which gives you fine-grained, pod-level AWS permissions without ever storing credentials inside the pods. Say that, and you've nailed it. It shows you know exactly what you're talking about.
So, we've covered the old, risky way. We've walked through the new, elegant solution. We've even looked at exactly where you'd use it. So I'll just leave you with this one question to think about. Now that you know the why and the how, what's the very first workload you're going to go and secure with IRSA? Go make it happen.